Now, so when you put together a PDM network, it looks something like this, okay, and so you can see you have the same kind of nodes as an activity on node. You have arrows representing relationships. You have where you have finish start relationship, you still show it without any qualifications, assumed finish start, that is the default. Where you have other relationships, you show it, so you can see this is a start start, and where there is lead or lag, of course you can show it here, and here again you have finish start, okay, with a lead, finish start with a lead, finish with a lag. So this is G and J, it is a finish. Okay, so this is what the network representation for PDM looks like.
So
now
plus represents lag.
Plus represents lag, there is a delay. Okay, so A will start after 3 days of delay, of 3 days later C can start. C cannot start 3 days before, before that. Okay, now let us look at this. Really these relationships cause some kind of issues, and this is very common to misrepresent the real world. So when we looked at activity on node itself, we found that finish start relationship, visualizing it, representing it correctly, we had to think through and get used to it. So in PDM it is more complex. So let us take a look at this problem. Now we have represented it earlier using an activity on node, and we had to split the activities, but let us take this and see how can we represent this using PDM. So can you work on it for a couple of minutes and then we can discuss it. So how many activities? 3 activities.
Start to start.
Okay.
To start relationships.
Okay. So it is, people still working on it, or? Okay, so let us look at alternative 1. We will say excavate, we will have a start to start, lay pipe, and backfill. Okay, now this is a very common, I would say, representation people do, because they look at the start parts of it and we finish. Now as we have learnt network analysis, this is a simple enough network, let us try to analyze it. Okay, can you, if you have you got this diagram, or have you got something different? Okay, now do an analysis. Okay, so as we start doing the analysis, we will see the early start. So laying, so you can see as we go, we have 3, 23, and then when we go to backfill, it goes to 21. There is a problem. Okay, so obviously we know physically that we have to backfill only after laying.
So finish to finish was also the
Okay.
finish to finish relationship.
Yeah, so we know now a finish to finish has to come somewhere.
In the first SS03, if we say that we are going to excavate the trench and after 3-day delay we are going to lay the pipe, and
we are going to start laying the pipe.
Yeah,
You can start laying.
We can start.
laying the pipe, and as we are laying the pipe, after that 10 days the
Yeah.
backfilling will start.
Yeah.
So that there will be 13, or it should start from 33.
Where is,
Why would you?
Oh no,
no, it is start relationship. If it was a finish start, then it would be different.
Sir, but ideally we will be laying the pipes until 23 days, but backfilling will be completed by 21. So it's not possible.
It's not possible, exactly. That's the point we are trying to illustrate.
Another relationship.
Right. So far, so this is a typical problem which comes up on when you try to implement a PDM. People represent only a single relationship between activities, and this happens, and then say, oh yes, I needed a finish relationship. Okay, so it's very common to, let me just finish this. So obviously this cannot happen. Okay, and when you go into, I'm just doing the backward pass, and you want to, first of all you want to connect these two. Okay, before you even do the finish, you cannot have a dangling activity. People try to connect these, but just doesn't work. you will have the network representation does not represent the project, you will have all kinds of values floating around and it will be not meaningful. So they say yes, we have not done a finish relationship. Okay, so you get into alternative 2, you will excavate trench, you will say look, laying pipe can be completed only after 3 days after excavation. You will say that backfilling can be finished only after 2 days of laying pipe, and then you will go with finish. Will this solve the problem? Why? Can you quickly just draw this representation and see what problem it will create? You have not covered your analysis of finish and start, but I assume you can apply the logic fairly simply in this.
So, but we don't know when the laying of pipe starts.
Right, but I am saying that laying of pipe can start, that is true. Okay, you do not know when laying of pipe starts, so I am saying it, right now you say let it start. So there is a lot of times I have heard people say let it start whenever so that it finishes on time. I am only controlling the finish, I do not want to control the start. So when you work backwards from here, so let's do the calculation. So as you go in, you have 0, you have 12. Now how do I calculate early start, early finish of laying pipe?
Oh, you have to do
Should be
it.
actually
It'll be 15.
15.
But the duration of
Right.
The duration is 20.
Right. So this is the problem we run into. Okay, so when you have to do this calculation, you have to go in the direction of the relationship.
Okay.
Okay. Now we run into all the same. So when I come back here, so now you can say okay, I have to lay pipe only when on the 0th day along with A, then the whole thing gets mixed up. What is the solution?
you need
Both.
Right. So the solution is, so this also does not work. So you need this. So what we are saying here is, I have to excavate trench. My laying pipe can start 3 days after excavation. Okay, and I am also constraining laying pipe with a finish relationship. And is this reality now?
So more time. Yeah.
This is more like the real project. Okay, and now there are software which will not allow you. So the difference between an AON and this is, now you have multiple relationships between activities. Okay, in the earlier case we only had a, so now you have the comp. So while you are saving on activities, your relationships are multiplying. Okay, and generally when you're in a planning engineer's position or in a construction, activities are easier to visualize than relationships. So as your relationship starts multiplying and getting more complex, unless you have really good control and understand why you are putting these relationships, things can get little bit dicey if you don't know what relationships you are represented by. And it doesn't stop here, it gets even more interesting. So if we solve this, what we can do a quick, so can you solve it along with this? So yeah, we won't worry about float. Let us look at this. So we go through the so we had the early start, the early finish. So here we now have 3, because this is supposed to start 3 days. I mean it cannot start within 3 days. So we are putting it as 3 is the early start. 23. Okay. Now coming from this side, we get 15.
20 will be good. Oh no, 23.
Okay, 15 minus 5.
So take 20.
Yes. So we will take 23, the max roll. Okay, now we come here 13, 21,
From there
25, 17. So now this is controlled by the finish relationship. Okay. So we do 25, 25. Now we come on to the backward. Okay, we have 25 here, 17. Okay, 17 we go back 17 with the start we are going back on this 10, I am sorry, back by 10 7, we go to 27 here, okay. But when we come through this relationship, it is 25 minus 2 23,
So it has to be 23.
3, so this is what we, okay. Now we come back here 3, this is 0, 12, 20, when we go back through this loop, that is 20 minus 3 is 28, this gives you the results. Now, so you can see PDM can require multiple relationship between activities, and these relationships, when to represent, how to constrain it, can be challenging. And while we can have multiple relationships, these relationships should not form a loop. Sometimes, for example, I mean in this case it's pretty straightforward, we will not form a loop. But if you do a lay pipe, instead of finish between this and it's the other way around, your software cannot take it, or you cannot do any calculation on it because it's iterative.
In backfilling,
Yeah.
why can't I start the activity on 13th and end it on 25th? Because it has to do for 8 days, but they can.
Right. So right now I am assuming constant duration. I am sorry, continuous activity. The point you raised is correct, and we will take that up in the next phase, or towards the end of this lecture I will discuss how further complexities of presence diagramming. Okay. So just to give you a little more insight on the question you asked, you're basically, and to the others, you're suggesting start this on 13 and extend it all the way to 25. Okay. So nothing prevents me from starting on 13, right, meaning I'm unconstrained. Only thing is then my duration hasn't changed. So right now I'm starting with I'm staying with constrained duration, meaning I'm constraining my duration to be continuous, the activity will be continuous. Okay, so if we actually look at the calculations we have done, okay, we have done it more out of the common sense of looking through the network and going, but basically we follow very similar rules to the activity or node, except that your relationships are more complex. So we did forward pass, and I have shown you all the 4 relationships that are possible. So what we have taken here, so if this is the preceding activity and the succeeding activity, the early start of the successor is the maximum of early finish of the predecessor plus the leader lag, or see this is the leader lag of a finish start relationship. Early start of the successor plus the leader lag of a start relationship. Okay, early finish, okay, plus the leader lag minus the duration. This is where we are saying duration is a continuous duration. Okay, and similarly we would calculate, so when you go into, you will calculate the early finish as the maximum of this plus the duration for 1 and 2. For the other one it gets computed. Similar rule applies to the late finish for the backward pass and the late durations. Okay, and like we have written down here, assume activity has to be done continuously, and when you assume the activity has to be done continuously, the flexibility of what you want out of a PDM is reduced. Okay, as you discussed, if I can have the flexibility of starting on 13 and when you go back here, starting on 13 and finishing on 25 is okay, it's okay. Okay, I should have that flexibility, but the analysis then becomes complicated. But that was the original intent of the PDM, that my start and my end is not constrained. So this is a PDM with a duration assumption.